What is a common challenge when using data lakes for machine learning? Is it A, limited data storage capacity? B, inability to store unstructured data? C, high cost of storage? Or D, risk of becoming a data swamp? The answer is D, risk of becoming a data swamp. Data lakes can become data swamps if not properly managed, leading to difficulties in data retrieval and quality issues. A company wants to store large volumes of sensor data for future machine learning projects. Which data storage solution should they consider? Is it A, data lake? B, data warehouse? C, relational database? Or D, NoSQL database? The answer is A, data lake. Data lakes are ideal for storing large volumes of raw data, including sensor data, for future processing and analysis. Which factor is least important when choosing a data repository for machine learning? Is it A, data volume? B, data variety? C, type of machine learning algorithm? Or D, data velocity? The answer is C, type of machine learning algorithm. Why this question may seem a bit tricky. All factors are important, but the specific type of machine learning algorithm is less critical than data volume, variety, and velocity. What is the primary purpose of a data warehouse in the context of machine learning? Is it A, to store structured data for analysis? B, to store unstructured data for machine learning? C, to process real-time data streams? Or D, to manage transactional data? The answer is A, to store structured data for analysis. Data warehouses are optimized for querying and reporting, making them suitable for structured data analysis in machine learning. Which of the following is a key feature of a data lake? Is it A, data is always structured? B, data is stored in its raw format? C, data is immediately processed upon entry? Or D, data is optimized for transactional processing? The answer is B, data is stored in its raw format. Data lakes can store data in its raw format, which allows for flexibility in data processing and analysis. Identify and implement a data ingestion solution. What is the primary purpose of using a data ingestion tool in data engineering? Is it A, to perform data analysis? B, to collect and import data from various sources? C, to visualize data? Or D, to secure data? The answer is B, to collect and import data from various sources. Data ingestion tools are primarily used to collect and import data from various sources into a data storage system for processing and analysis. Which of the following is a common challenge when implementing a data ingestion solution? Is it A, data visualization? B, data encryption? C, data quality? Or D, data redundancy? The answer is C, data quality. Data quality is a common challenge because data from various sources can be inconsistent or incomplete. Which protocol is commonly used for real-time data ingestion? Is it A, Apache Kafka? B, FTP? C, SMTP? Or D, HTTP? The answer is A, Apache Kafka. Apache Kafka is widely used for real-time data ingestion due to its high throughput and scalability. A company needs to ingest data from IoT devices in real time. Which solution should they consider implementing? Is it A, batch processing with Hadoop? B, using FTP servers? C, implementing Apache Kafka? Or D, using email notifications? The answer is C, implementing Apache Kafka. For real-time data ingestion from IoT devices, Apache Kafka is a suitable choice due to its ability to handle high-throughput data streams. Which of the following is not a benefit of using a cloud-based data ingestion solution? Is it A, scalability, B, flexibility, C, cost-effectiveness, or D, guaranteed data accuracy? The answer is D, guaranteed data accuracy. Why this question may seem a bit tricky? Cloud-based solutions offer scalability, flexibility, and cost-effectiveness, but they do not inherently guarantee data accuracy. What is a key advantage of using a managed data ingestion service? Is it A, reduced operational overhead, B, increased data latency, C, higher cost compared to self-managed solutions, or D, limited scalability? The answer is A, reduced operational overhead. Managed services reduce the operational overhead by handling infrastructure management, scaling, and maintenance, allowing engineers to focus on data processing and analysis.
If you're finding this helpful, please take a minute to like this video and subscribe to our channel for more practice exams, useful tips, and complimentary study sessions with Birdsey.
Identify and implement a data transformation solution. What is the primary purpose of using ETL, extract transform load, in data engineering? Is it A, to store data in a database, B, to transform and prepare data for analysis, C, to secure data from unauthorized access, or D, to visualize data in dashboards? The answer is B, to transform and prepare data for analysis. ETL is used to extract data from various sources, transform it into a suitable format, and load it into a data warehouse or other system for analysis. Which of the following is a common data transformation operation? Is it A, data aggregation, B, data encryption, C, data replication, or D, data deletion? The answer is A, data aggregation. Data aggregation is a common transformation operation that summarizes data, often used in data engineering. In a data pipeline, what is the role of a data transformation tool? Is it A, to store data securely, B, to visualize data, C, to modify and convert data formats, or D, to extract data from sources? The answer is C, to modify and convert data formats. Data transformation tools modify and convert data into a format suitable for analysis or storage. A company needs to transform raw sales data into a format suitable for monthly reporting. Which data transformation process should they focus on? Is it A, data encryption, B, data replication, C, data cleansing, or D, data aggregation? The answer is D, data aggregation. Data aggregation is essential for summarizing raw data into monthly reports, making it suitable for analysis. When transforming data, which operation might inadvertently lead to data loss? Is it A, data normalization, B, data aggregation, C, data encryption, or D, data replication? The answer is B, data aggregation. Why this question may seem a bit tricky, aggregation can lead to data loss if details are summarized or omitted, unlike other operations that preserve data. What is a common method for handling missing data during data transformation? Is it A, imputation, B, normalization, C, aggregation, or D, filtering? The answer is A, imputation. Imputation is a common method used to handle missing data by replacing missing values with estimated ones, such as the mean or median. Which data transformation technique is used to reduce the dimensionality of a dataset? Is it A, normalization, B, imputation, C, principal component analysis, or D, data cleansing? The answer is C, principal component analysis. Dimensionality reduction techniques like PCA reduce the number of variables in a dataset while preserving important information. Exploratory data analysis. Sanitize and prepare data for modeling. What is the primary purpose of handling missing data during data preparation? Is it A, to ensure the dataset is complete and reliable, B, to increase the dataset size, C, to reduce computational cost, or D, to enhance data visualization? The answer is A, to ensure the dataset is complete and reliable. Handling missing data ensures that the dataset is complete and reliable, which is crucial for building accurate models. Which technique is commonly used to handle categorical variables in data preparation? Is it A, normalization, B, standardization, C, one-hot encoding, or D, PCA? The answer is C, one-hot encoding. One-hot encoding is a popular method to convert categorical variables into a numerical format suitable for modeling. Why is it important to remove outliers during data preparation? Is it A, to increase data variability, B, to prevent skewed results, C, to enhance data visualization, or D, to simplify data storage? The answer is B, to prevent skewed results. Outliers can skew the results of statistical analyses and model predictions, leading to inaccurate conclusions. You are preparing a dataset for modeling and notice several columns with high cardinality categorical variables. What should you consider to effectively handle these variables? Is it A, apply normalization, B, use PCA, C, perform one-hot encoding, or D, consider target encoding? The answer is D, consider target encoding. High cardinality can lead to large feature spaces. Techniques like target encoding can help manage this by reducing dimensionality. When preparing data, why might you choose to impute missing values rather than remove rows with missing data? Is it A, to ensure data integrity, B, to simplify data analysis, C, to maintain dataset size, or D, to improve data accuracy? The answer is C, to maintain dataset size. Why this question may seem a bit tricky. Imputation can preserve data size and structure, but it's not always the best choice if the missing data is not random. What is the primary goal of data normalization in the context of data preparation? Is it A, to increase data variance, B, to ensure features contribute equally, C, to enhance data redundancy, or D, to improve data sparsity? The answer is B, to ensure features contribute equally. Normalization scales data to a standard range, typically 0 to 1, to ensure that features contribute equally to the model's performance. Which method is commonly used to handle missing numerical data in datasets? Is it A, main imputation, B, one-hot encoding, C, data binning, or D, feature scaling? The answer is A, mean imputation. Mean imputation replaces missing values with the average of the available data, maintaining dataset size and structure. Perform feature engineering. What is the primary purpose of feature scaling in feature engineering? Is it A, to increase the dataset size, B, to standardize the range of independent variables, C, to reduce the number of features, or D, to improve data visualization? The answer is B, to standardize the range of independent variables. Feature scaling ensures that all features contribute equally to the distance calculations in algorithms like k-nearest neighbors and gradient descent optimization. Which technique is used to handle categorical variables in feature engineering? Is it A, one-hot encoding, B, normalization, C, PCA, or D, SMOT? The answer is A, one-hot encoding. One-hot encoding is a common method to convert categorical variables into a numerical format suitable for machine learning models. What is the main goal of feature selection in feature engineering? Is it A, to increase the number of features, B, to create new features, C, to improve model performance by reducing overfitting, or D, to ensure all features have equal importance? The answer is C, to improve model performance by reducing overfitting. Feature selection aims to improve model performance by reducing overfitting and enhancing interpretability by selecting the most relevant features. You have a data set with missing values in several features. What is a common technique to handle these missing values? Is it A, feature scaling, B, one-hot encoding, C, feature selection, or D, imputation? The answer is D, imputation. Imputation is a common technique used to fill in missing values, often using the mean, median, or mode of the feature. In feature engineering, why might you choose to use polynomial features? Is it A, to capture nonlinear relationships, B, to reduce model complexity, C, to handle missing data, or D, to improve data normalization? The answer is A, to capture nonlinear relationships. Why this question may seem a bit tricky. Polynomial features can increase model complexity, which might seem counterproductive. However, they can capture nonlinear relationships that linear models cannot. What is the purpose of one-hot encoding in feature engineering? Is it A, to normalize numerical data, B, to convert categorical variables into numerical format, C, to handle missing values, or D, to reduce dimensionality? The answer is B, to convert categorical variables into numerical format. One-hot encoding is used to convert categorical variables into a format that can be provided to ML algorithms to do a better job in prediction. Which feature engineering technique can help improve model performance by creating new features from existing ones? Is it A, feature scaling, B, feature selection, C, feature transformation, or D, feature imputation? The answer is C, feature transformation. Feature transformation involves creating new features from existing ones to improve model performance. Analyze and visualize data for machine learning. What is the primary purpose of exploratory data analysis in machine learning? Is it A, to train machine learning models, B, to understand data patterns and anomalies, C, to deploy machine learning models, or D, to collect new data? The answer is B, to understand data patterns and anomalies. Exploratory data analysis helps in understanding the underlying structure of the data, identifying patterns, and detecting anomalies, which is crucial for building effective machine learning models. Which visualization technique is most suitable for showing the distribution of a single continuous variable? Is it A, scatter plot, B, R chart, C, histogram, or D, line chart? The answer is C, histogram. Histograms are ideal for displaying the distribution of a single continuous variable, showing frequency of data points within specified ranges. What does a box plot primarily display about a dataset? Is it A, median, quartiles, and outliers, B, Mean and standard deviation. C. Correlation between variables. Or D. Frequency distribution. The answer is A. Median, quartiles, and outliers. A box plot displays the median, quartiles, and potential outliers of a dataset, providing a visual summary of its distribution. You have a dataset with multiple features and suspect some may be highly correlated. Which visualization would help you identify these correlations effectively? Is it A. Box plot, B. Histogram, C. Line chart, or D. Heat map of correlation matrix? The answer is D. Heat map of correlation matrix. A heat map of the correlation matrix provides a visual representation of correlations between multiple features, making it easy to spot high correlations. When performing exploratory data analysis, why might you choose to use a pair plot? Is it A. To visualize time series data, B. To visualize relationships between pairs of variables, C. To summarize categorical data, or D. To display hierarchical data? The answer is B. To visualize relationships between pairs of variables. Why this question may seem a bit tricky. Pair plots are useful for visualizing relationships between multiple pairs of variables, but they can be mistaken for being too simplistic or only for small datasets. Which plot is most effective for visualizing the relationship between two continuous variables? Is it A. Bar plot, B. Scatter plot, C. Histogram, or D. Pie chart? The answer is B. Scatter plot. A scatter plot is ideal for visualizing the relationship between two continuous variables, as it displays individual data points and can reveal correlations or patterns. What is the main purpose of using a heat map in exploratory data analysis? Is it A. To visualize correlations between variables, B. To show the distribution of a single variable, C. To compare categorical data, or D. To display time series data? The answer is A. To visualize correlations between variables. Heat maps are primarily used to visualize the correlation matrix of a dataset, making it easier to identify patterns and relationships between variables. Modeling. Frame business problems as machine learning problems. What is the primary purpose of framing a business problem as a machine learning problem? Is it A. To identify the right algorithms and data needed, B. To reduce the cost of data processing, C. To ensure data privacy and security, or D. To increase the speed of data collection? The answer is A. To identify the right algorithms and data needed. Framing a business problem as a machine learning problem helps identify the right algorithms and data needed to solve the problem effectively. Which of the following is a key step in framing a business problem for machine learning? Is it A. Selecting the programming language, B. Choosing the cloud service provider, C. Defining the success criteria, or D. Hiring a data scientist? The answer is C. Defining the success criteria. Defining the success criteria is crucial to measure the effectiveness of the machine learning solution. What is a common outcome of improperly framing a business problem as a machine learning problem? Is it A. Increased data storage requirements, B. Higher computational costs, C. Improved model accuracy, or D. Poor model performance? The answer is D. Poor model performance. Improper framing can lead to selecting inappropriate models, resulting in poor performance. A retail company wants to predict customer churn. What is the first step in framing this as a machine learning problem? Is it A. Collecting customer data, B. Identifying the target variable. C. Choosing a machine learning algorithm. Or D. Deploying the model. The answer is B. Identifying the target variable. Identifying the target variable is crucial to understand what the model should predict. Why might a business problem framed as a classification task actually be better suited for regression? Is it A. The problem involves categorical data. B. The problem requires predicting discrete labels. C. The output is a continuous value. Or D. The data is imbalanced. The answer is C. The output is a continuous value. Why this question may seem a bit tricky. Classification and regression are often confused. If the output is continuous, regression is more appropriate, even if it seems like a classification problem initially. What is the primary goal when framing a business problem as a machine learning problem? Is it A. Translate the problem into a machine learning task. B. Identify the most complex algorithm. C. Focus on data collection. Or D. Ensure maximum data storage. The answer is A. Translate the problem into a machine learning task. The primary goal is to translate the business problem into a machine learning task that can be solved using data and algorithms. Which of the following is essential when defining a machine learning problem? Is it A. Choosing the algorithm first. B. Defining input and output variables. C. Maximizing data volume. Or D. Ensuring data privacy. The answer is B. Defining input and output variables. Defining the input and output variables is crucial to set the boundaries of the problem. Select the appropriate model for a given machine learning problem. Which model is most suitable for predicting a continuous numerical outcome? Is it A. Linear regression. B. K-means clustering. C. Decision tree classifier. Or D. Naive Bayes. The answer is A. Linear regression. Linear regression is ideal for predicting continuous numerical outcomes as it models the relationship between a dependent variable and one or more independent variables. Which model is best suited for classifying text data into predefined categories? Is it A. Linear regression. B. K-means clustering. C. Naive Bayes. Or D. Random forest regressor. The answer is C. Naive Bayes. Naive Bayes is effective for text classification due to its simplicity and efficiency, especially with large datasets. What model is typically used for image recognition tasks? Is it A. Logistic regression. B. Support vector machine. C. K-nearest neighbors. Or D. Convolutional neural network. The answer is D. Convolutional neural network. Convolutional neural networks are designed to process data with grid-like topology, making them ideal for image recognition. You need to group customers into segments based on purchasing behavior. Which model should you choose? Is it A. Linear regression. B. K-means clustering. C. Decision tree classifier. Or D. Principal component analysis. The answer is B. K-means clustering. K-means clustering is suitable for segmenting customers into groups based on similar purchasing behaviors. Which model would you choose for a binary classification problem with a large feature set? Is it A. Linear regression. B. Support vector machine. C. K-means clustering. Or D. Random forest regressor. The answer is B. Support vector machine. Why this question may seem a bit tricky. Support vector machines are effective for binary classification, especially with large feature sets, but can be computationally intensive. Which model is most suitable for predicting the likelihood of a customer churning? Is it A, logistic regression, B, linear regression, C, k-means clustering, or D, decision trees? The answer is A, logistic regression. Logistic regression is commonly used for binary classification problems, such as predicting whether a customer will churn. Train machine learning models. What is the primary purpose of using a validation dataset during the training of a machine learning model? Is it A, to train the model parameters, B, to tune hyperparameters and evaluate model performance, C, to test the final model performance, or D, to increase the size of the training dataset? The answer is B, to tune hyperparameters and evaluate model performance. A validation dataset is used to tune hyperparameters and evaluate the model's performance during training, helping to prevent overfitting. Which technique is commonly used to prevent overfitting in machine learning models? Is it A, increasing the number of features, B, using a smaller training dataset, C, applying regularization techniques, or D, reducing the number of epochs? The answer is C, applying regularization techniques. Regularization techniques like L1 and L2 are used to prevent overfitting by adding a penalty to the loss function. What is the role of a learning rate in training machine learning models? Is it A, it determines the step size during optimization, B, it defines the model's architecture, C, it sets the number of training epochs, or D, it adjusts the dataset size? The answer is A, it determines the step size during optimization. The learning rate determines the size of the steps taken during optimization, affecting convergence speed and stability. You are training a neural network, and notice that the validation loss is much higher than the training loss. What does this indicate? Is it A, the model is underfitting, B, the learning rate is too high, C, the model has a high bias, or D, the model is overfitting? The answer is D, the model is overfitting. A higher validation loss compared to training loss typically indicates overfitting, where the model performs well on training data but poorly on unseen data. During model training, which factor is least likely to affect the convergence speed? Is it A, learning rate, B, data preprocessing, C, batch size, or D, optimizer choice? The answer is B, data preprocessing. Why this question may seem a bit tricky. While data preprocessing is crucial for model performance, it doesn't directly affect convergence speed like learning rate or batch size. What is the main purpose of using dropout during the training of a neural network? Is it A, to prevent overfitting, B, to increase the learning rate, C, to decrease the model's complexity, or D, to improve data augmentation? The answer is A, to prevent overfitting. Dropout is used to prevent overfitting by randomly setting a fraction of input units to 0 at each update during training time. Perform hyperparameter optimization. What is the primary purpose of hyperparameter optimization in machine learning models? Is it A, to improve model performance, B, to reduce model size, C, to increase data processing speed, or D, to simplify the model architecture? The answer is A, to improve model performance. Hyperparameter optimization aims to improve model performance by finding the best set of hyperparameters, which are not learned from the data. Which of the following is a common method used for hyperparameter optimization? Is it A, random sampling, B, grid search, C, cross-validation, or D, data augmentation? The answer is B, Grid search. Grid search is a systematic method for hyperparameter optimization that evaluates all possible combinations of parameters. In hyperparameter optimization, what is the role of a validation set? Is it A, to train the model, B, to test the model, C, to evaluate model performance during tuning, or D, to increase the dataset size? The answer is C, to evaluate model performance during tuning. A validation set is used to evaluate the model's performance during hyperparameter tuning, preventing overfitting to the training data. You are using a random search for hyperparameter optimization on a deep learning model. What is a potential advantage of this approach over grid search? Is it A, it guarantees finding the optimal parameters, B, it is faster because it evaluates fewer combinations, C, it requires less computational power, or D, it explores a broader range of hyperparameter values? The answer is D, it explores a broader range of hyperparameter values. Random search can be more efficient than grid search because it explores a broader range of hyperparameter values, potentially finding better configurations faster. When performing hyperparameter optimization, why might it be misleading to rely solely on the training accuracy? Is it A, training accuracy is always reliable, B, it may not reflect performance on unseen data, C, it is the best metric for model evaluation, or D, it ensures the model is not overfitting? The answer is B, it may not reflect performance on unseen data. Why this question may seem a bit tricky. Training accuracy can be misleading because it may not reflect the model's performance on unseen data, leading to overfitting. What is the main goal of hyperparameter optimization in machine learning? Is it A, to maximize model performance on unseen data, B, to minimize training time, C, to increase the complexity of the model, or D, to reduce the number of features? The answer is A, to maximize model performance on unseen data. Hyperparameter optimization aims to find the best set of hyperparameters that maximize the model's performance on unseen data. Evaluate machine learning models. What is the primary purpose of using a confusion matrix in evaluating machine learning models? Is it A, to assess the accuracy and error types of a model, B, to visualize the distribution of data features, C, to determine the optimal hyperparameters, or D, to calculate the model's training time? The answer is A, to assess the accuracy and error types of a model. A confusion matrix provides a detailed breakdown of prediction results, showing true positives, true negatives, and false negatives, which helps in understanding model performance. Which metric is most appropriate for evaluating a model when dealing with imbalanced datasets? Is it A, accuracy, B, mean absolute error, C, F1 score, or D, R squared? The answer is C, F1 score. F1 score is suitable for imbalanced datasets as it considers both precision and recall, providing a balance between false positives and false negatives. What does the ROC curve illustrate in model evaluation? Is it A, the model's precision versus recall, B, the trade-off between true positive rate and false positive rate, C, the distribution of predicted probabilities, or D, the model's accuracy over time? The answer is B, the trade-off between true positive rate and false positive rate. The ROC curve plots the true positive rate against the false positive rate, showing the trade-off between sensitivity and specificity. A company wants to reduce false negatives in its fraud detection model. Which metric should they focus on improving? Is it A, precision, B, accuracy, C, specificity, or D, Recall. The answer is D. Recall. Improving recall will reduce false negatives, as recall measures the proportion of actual positives correctly identified. Why might a high accuracy not always indicate a good model performance? Is it A, it always indicates good performance? B, it reflects the model's precision? C, it may not account for class imbalance? Or D, it shows the model's recall? The answer is C, it may not account for class imbalance. Why this question may seem a bit tricky. High accuracy can be misleading, especially in imbalanced datasets, where the model may predict the majority class well, but fail on the minority class. What is the purpose of using cross-validation in evaluating machine learning models? Is it A, to increase the model's accuracy? B, to provide a more reliable estimate of model performance? C, to reduce the size of the dataset? Or D, to improve the speed of model training? The answer is B, to provide a more reliable estimate of model performance. Cross-validation helps in assessing the model's performance by splitting the data into multiple subsets, training on some and validating on others. This reduces overfitting and provides a more reliable estimate of model performance.
If you're finding this helpful, please take a minute to like this video and subscribe to our channel for more practice exams, useful tips, and complimentary study sessions with Birdsey.
Machine learning implementation and operations. Build ML solutions for performance, availability, scalability, resiliency, and fault tolerance. What is a common strategy to ensure high availability in machine learning models deployed on cloud platforms? Is it A, implementing load balancing? B, using a single large instance? C, increasing the instance size? Or D, reducing the number of instances? The answer is A, implementing load balancing. Load balancing distributes incoming traffic across multiple instances, ensuring that if one instance fails, others can handle the load, maintaining availability. A company needs to ensure their ML model can handle sudden spikes in user demand. What approach should they take to maintain performance? Is it A, deploying on a single large instance? B, implementing auto-scaling? C, using a fixed number of instances? Or D, reducing model complexity? The answer is B, implementing auto-scaling. Auto-scaling automatically adjusts the number of instances based on demand, ensuring performance is maintained during spikes. Which technique is essential for ensuring the fault tolerance of a machine learning system? Is it A, using a single data center? B, increasing model complexity? C, implementing redundancy? Or D, reducing training data size? The answer is C, implementing redundancy. Redundancy involves having backup systems or components that can take over in case of failure, ensuring fault tolerance. What is a potential downside of over-provisioning resources for a machine learning model in production? Is it A, improved model accuracy? B, enhanced fault tolerance? C, increased latency? Or D, higher operational costs? The answer is D, higher operational costs. Why this question may seem a bit tricky. Over-provisioning might seem beneficial for performance, but it leads to unnecessary costs without improving efficiency. What is the primary benefit of using containerization for deploying machine learning models? Is it A, increased model accuracy? B, enhanced portability and scalability? C, reduced training time? Or D, improved data security? The answer is B, enhanced portability and scalability. Containerization provides a consistent environment across different stages of deployment, enhancing scalability and portability. What is a key advantage of using load balancing in a machine learning deployment? Is it A, it distributes traffic evenly across servers? B, it reduces the need for data pre-processing? C, it automatically scales storage capacity? Or D, it ensures data consistency across databases? The answer is A, it distributes traffic evenly across servers. Load balancing distributes incoming network traffic across multiple servers, ensuring no single server becomes overwhelmed, which enhances performance and availability. Apply basic AWS security practices to ML solutions. Which AWS service is primarily used to manage access permissions for ML models and data? Is it A, AWS Identity and Access Management? B, AWS Lambda? C, Amazon S3? Or D, AWS CloudTrail? The answer is A, AWS Identity and Access Management. AWS Identity and Access Management is used to manage access permissions for AWS resources, including ML models and data. What is a key security practice when deploying ML models on AWS? Is it A, using public S3 buckets? B, encrypting data at rest and in transit? C, disabling logging? Or D, using default security groups? The answer is B, encrypting data at rest and in transit. Encrypting data at rest and in transit is a key security practice to protect sensitive information. Which AWS service provides a centralized view of security and compliance across AWS accounts? Is it A, AWS CloudWatch? B, AWS Shield? C, AWS Security Hub? Or D, AWS Config? The answer is C, AWS Security Hub. AWS Security Hub provides a comprehensive view of security alerts and compliance status across AWS accounts. Your team is deploying an ML model on AWS and needs to ensure that only authorized users can access the model. Which AWS feature should you implement? Is it A, AWS Lambda? B, Amazon S3? C, AWS CloudTrail? Or D, IAM roles? The answer is D, IAM roles. IAM roles allow you to define who can access the model and what actions they can perform, ensuring only authorized users have access. When configuring security for an ML solution on AWS, which practice might lead to a false sense of security if not properly implemented? Is it A, using multi-factor authentication? B, enabling encryption without key management? C, implementing VPC keying? Or D, using AWS WAF? The answer is B, enabling encryption without key management. Why this question may seem a bit tricky, simply enabling encryption without managing keys properly can lead to vulnerabilities, as unauthorized access to keys can compromise data security. Which AWS service is used to encrypt data at rest for ML solutions? Is it A, AWS Key Management Service? B, AWS Identity and Access Management? C, Amazon Guard Duty? Or D, AWS CloudTrail? The answer is A, AWS Key Management Service. AWS Key Management Service is used to encrypt data at rest, ensuring that sensitive information is protected. Deploy and operationalize ML solutions. What is the primary purpose of using a model registry in machine learning operations? Is it A, to track and manage different versions of models? B, to store raw data for training? C, to deploy models to production environments? Or D, to automate hyperparameter tuning? The answer is A, to track and manage different versions of models. A model registry is used to track and manage different versions of machine learning models, ensuring reproducibility and facilitating collaboration. Which AWS service is primarily used for deploying machine learning models at scale? Is it A, AWS Lambda, B, Amazon SageMaker, C, AWS Glue, or D, Amazon Redshift? The answer is B, Amazon SageMaker. Amazon SageMaker is designed for building, training, and deploying machine learning models at scale. What is a common method to monitor the performance of a deployed machine learning model? Is it A, using a static dashboard, B, manual logging of predictions, C, tracking metrics like accuracy and F1 score, or D, deploying models on multiple platforms? The answer is C, tracking metrics like accuracy and F1 score. Monitoring model performance often involves tracking metrics such as accuracy, precision, recall, and F1 score over time. Your team deployed a machine learning model that is underperforming in production. What is a recommended first step to address this issue? Is it A, retrain the model with more data, B, increase the model's complexity, C, deploy a backup model, or D, check for data drift in input features? The answer is D, check for data drift in input features. Checking for data drift helps identify if the input data distribution has changed, which can affect model performance. In a continuous deployment pipeline for machine learning, what is a potential risk of automating model updates without human oversight? Is it A, increased deployment speed, B, deploying models with unnoticed issues, C, reduced operational costs, or D, improved model accuracy? The answer is B, deploying models with unnoticed issues. Why this question may seem a bit tricky. Automation is beneficial, but without oversight, there's a risk of deploying models that may not perform well due to unnoticed issues. What is the primary benefit of using containerization for deploying machine learning models? Is it A, consistency across environments, B, improved model accuracy, C, reduced training time, or D, enhanced data privacy? The answer is A, consistency across environments. Containerization provides consistency across environments, ensuring that the model runs the same way in development, testing, and production.
Thanks for joining us today. If you found this video helpful, subscribe to our channel for more practice exams, tips, and tricks. And don't forget to visit birdsey.ai for complimentary study sessions with Birdsey, your AI-powered study partner.